Okay. Hello, my name is Rachel Charish, and my thesis is Beyond the Limits of the Lower River Shannon Special Area of Conservation, Trends in the Presence and Foraging Behavior of Bottlenose Dolphin and Harbour Porpoise at Ballyheigue Bay, Brandon Bay, and the Maharees, County Kerry. So, 25 species of cetacean have been recorded in Irish waters, and all are listed under Annex 4 of the EC Habitats Directive. But Annex 2 specifically lists Harbour porpoise and bottlenose dolphin as cetacean species for which special areas of conservation, or SACs, must be established. So this is a map of the cetacean SACs in Ireland, and the ones in blue have Harbour porpoise as their qualifying interest, and then the ones in purple, bottlenose dolphin. And the Lower River Shannon SAC is the focus of this study. Now, monitoring is an important part of managing special areas of conservation and tracking their effectiveness, and we have various monitoring techniques. So on the one hand, with visual monitoring, that could be boat-based or aerial surveys, for example, and those methods have high spatial resolution but limited temporal resolution. So it's not possible to operate a vessel during adverse weather conditions or carry out visual surveys at nighttime during darkness, and then there's also the cost of the vessel fuel. Then we have acoustic monitoring techniques, and in passive acoustic monitoring, a hydrophone is towed behind a vessel, and we can record cetacean vocalizations that way, but once again, we have the constraints of operating the vessel. On the other hand, with static acoustic monitoring, a device is deployed in a set location, and then it remains in place, and so we can obtain data continuously for months, and this allows us also to obtain data during adverse weather and at nighttime. Now, to understand a little bit more about how acoustic monitoring works, we need to know about the vocalization characteristics of the cetaceans, and we'll focus here on Harbour porpoise and bottlenose dolphin because they are both listed under Annex 2. So Harbour porpoises produce one type of vocalization, which are their clicks, and these clicks are narrowband and high frequency, or MBHF, in the 120 to 150 kilohertz range. Whereas bottlenose dolphins produce three types of vocalization, which are their clicks, whistles, and burst pulse sounds. And another thing we can measure is the interclick interval, which is the amount of time that elapses between each click in a click train. And this changes depending on the function of the vocalization. So when the interclick interval is less than 10 milliseconds, that's indicative of foraging behavior by both bottlenose dolphins and Harbour porpoise. Now, one of the reasons this monitoring is so important is because cetaceans are so highly mobile, and the boundaries of MPAs and SACs are typically fixed, so that can be an issue when species exhibit range expansions or changes in their distribution. And I have an example here of the Moray Firth SAC in Scotland, where dolphins expanded their range up to 300 kilometers further south than the limits of the SAC. So the recommendation is for more dynamic management of MPAs, taking into account temporal processes rather than just the spatial boundaries. And as I said, the focus of this study is the Lower River Shannon SAC. So that's located on the west coast of Ireland between Limerick and the Loop Head and Kerry Head seaward limits. And its qualifying interest is the Shannon bottlenose dolphin population, which is a stable population of 139 individuals. And although the estuary is assumed to represent the core habitat for this population, there have been sightings of Shannon dolphins in bays both to the north and to the south of the estuary. And between 2008 and 2016, Levesque et al. Carried out a series of surveys in Trolley Bay and Brandon Bay, which are both to the south of the estuary, and they observed dolphins on 90% of the trips, and 96% of these dolphins were matched to the Shannon population catalog. So, visual monitoring has shown that there is presence of Shannon estuary dolphins outside of the estuary, and the focus of this study is to use acoustic monitoring to investigate the presence and foraging of Shannon dolphins in bays beyond the limits of the Lower River Shannon SAC. And the research questions I'll address are bottlenose dolphins present in Ballyheigue Bay, Brandon Bay, and the Maharees? And these are three bays all located 10 to 30 kilometers to the south of the Shannon estuary. And we'll also look at Harbour porpoises because they are the most commonly encountered cetacean in Irish waters and also listed under Annex 2. And then, is there co-occurrence of bottlenose dolphins and Harbour porpoises? Do the sites represent potential foraging habitat? And what are the environmental drivers of bottlenose dolphin and Harbour porpoise presence and foraging at these sites? So these are locations, Brandon Bay, Maharees, and Ballyheigue Bay, and you can see the mouth of the Shannon estuary to the north. And at each site, we deployed a CPOD, which is a static acoustic monitoring device. And CPODs detect tonal clicks in the marine environment in the 20 kilohertz to 160 kilohertz frequency range. So when the clicks are repeating, we call that a click train. And click trains can be cetacean in origin, or they can originate from boat sonar, or even a snapping shrimp. So the CPOD uses the acoustic properties of the click trains to discriminate and to determine if it's cetacean in origin. So we deployed the CPODs and then left them in place for several months. And when we retrieve them, we extract the data in the CPOD software. And that looks like this. You can see the sound pressure level of the clicks on the y-axis here. And the bottom window shows the raw data. And then we apply species classifier and quality filters. And on the top window, those orange lines represent dolphin detections. And if those were purple, that would be Harbour porpoise or MBHF instead. So the methods I followed was firstly to extract the data in terms of detection positive minutes per hour, and then also the click train characteristics. And once again, the reason that we're interested in the minimum interclick interval is because when that's under 10 milliseconds, we can use that as a proxy for foraging. And then I filtered the data and constructed two different data sets. So presence data set and foraging. And for presence, that was the detection positive minutes converted to binomial format. And then with foraging, I split that into two ways of looking at foraging. So a click train based foraging data set, where I categorized each individual click train as 0 or not foraging if the minimum interclick interval was greater than 10 milliseconds, and 1 or foraging if it was less than 10 milliseconds. And also a forage positive hour based data set, where instead of looking at the individual click trains, we're looking at each hour of the study and categorizing that according to whether there was foraging or not. And the reason that I did that was because cetacean data can be autocorrelated when we're looking at the click trains. So by broadening our view, we reduce some of the dependency. And then these are the environmental variables that we used in the presence and foraging models. And the reason these particular variables were used was because they've all been used previously to model Shannon dolphin presence within the estuary, but not yet outside of it. And they can be incorporated into management plans. So we have Diel, which can be morning, day, evening, or night. Tidal cycle, which is ebb, low, flood, or high tide. Tidal phase, which is neap, transitional, or spring tide. And then months in the presence of other species. So we incorporate those into our models, and we use a generalized linear modeling approach, which is appropriate for binary data with non-normal error distribution. However, GLMs assume independence of observations, and cetacean acoustic data frequently has temporal autocorrelation. So to determine whether there was autocorrelation, we examine an autocorrelation function plot or an ACF plot of the model residuals. And then when autocorrelation was detected, we used a generalized estimating equations approach instead, which is a modeling technique that takes autocorrelation into account by grouping the data into blocks and specifying a correlation structure. So Julian date was used to group the data into blocks, meaning that all of the observations from within a day are more likely to be correlated with each other than with observations on other days. And this is just to show what those autocorrelation function plots look like. So on the left would be when there is temporal autocorrelation, and all of the lines are crossing the 95% confidence bounds. And then on the right is when there's no temporal autocorrelation, and all of the lines are within the confidence bounds. So this is how the models were specified, whether they were GLM or GE, and this was done separately for each species and for each location and for foraging and presence. And then the model selection approach was to drop non-significant variables until only significant predictors remained. And to validate the models and make sure that they're working properly, we use confusion matrices to construct receiver operating characteristic plots. So that looks like this. You want to see this curve above the diagonal line, and then also looking at the area under the curve, which is a value ranging from 0 to 1, where 0.5 implies the performance is no better than random chance. And as the value approaches 1, that means better predictive power of the model. So what were the results? Well, there was very little dolphin presence at Ballyheigue Bay, where dolphins were detected on only 2 out of the 840 hours monitored. And then at the Maharees, we have slightly higher dolphin presence, and Harbour porpoises present on 91% of days. And in Brandon Bay, dolphins are present on 92% of days and Harbour porpoises on 89% of days. In terms of co-occurrence, At Ballyheigue Bay and the Maharees, we have no examples of dolphin encounters and harbour porpoise encounters occurring within the same half hour. And in Brandon Bay, 80% of dolphin and harbour porpoise encounters are separated by at least 30 minutes. So we can see that separation visually in the waffle plot, where the light blue squares represent encounters that are further apart in time than 30 minutes between dolphins and porpoises. So for foraging, when dolphins were present in Brandon Bay, they spent more than half of their time foraging, and dolphins foraged on 20% of all hours monitored at Brandon Bay, and harbour porpoises on 31% of all hours monitored. And then at the Maharees, we see lower rates of foraging. Now, these box plots show what is significant in each situation. So for example, for dolphin presence in Brandon Bay, tidal cycle, month, and the presence of harbour porpoises were all significant predictors. However, as we go through these, what you can see is the amount of variation, and we can come back to these during the questions, but you can see that what is significant changes depending on whether we're looking at presence or foraging, which location we're looking at, and also whether we're looking at dolphin or harbour porpoise. But let's summarize the overall trends. So what we found was that predictors for presence and foraging are site-specific and species-specific. So presence was influenced by all of tidal cycle, tidal phase, dial, and month in various combinations, while foraging was only influenced by dial and month. So for example, in Brandon Bay, tidal cycle was a significant predictor of dolphin presence, but it was not at the Maharees site. And previous studies have shown this variability in the response to tide, and that could be dependent on the shape of the site. So for example, whether it's an open bay or a narrow channel, and it's likely that the response to tidal cycle and tidal phase are influenced by physical characteristics, such as the shape and bathymetry. Then turning to dial and month, we see August-September peaks in dolphin presence and foraging, although foraging occurred at different times of day between the Brandon Bay and Maharees sites. And so this August-September peak could be explained by foraging on Atlantic salmon, whereas for harbour porpoises, the presence peaks later in the year, so October-November peaks in presence, a November peak in foraging, and nocturnal foraging at both sites. And that could be explained by foraging on Atlantic herring, since Brandon Bay and the Maharees are both located adjacent to the Brandon Head herring spawning area. For co-occurrence, we found temporal partitioning, where harbour porpoises and dolphins occurred at both sites, but at different times of the day and in different months. And previous studies have also found temporal partitioning between harbour porpoises and bottlenose dolphins, and some mechanisms to explain that could be competition for resources leading to aggressive encounters and avoidance, or infanticidal behaviour by bottlenose dolphins, since bottlenose dolphins exhibit this behaviour towards their own calves, and harbour porpoises are a similar size, and so that could be a case of mistaken identity. The main limitations of the study were that the monitoring was carried out over only a single year, so there's no replicate for months, and we can't test the significance of season. The monitoring period at Ballyheigue Bay was shorter compared to the other sites, so we don't know truly lower bottlenose dolphin presence in Ballyheigue Bay, or if that's just an artifact of the time of year and the shorter monitoring period. And only a single C-pod was deployed in each location. And because C-pods have a limited detection range for harbour porpoise and bottlenose dolphin, it means that we could end up underestimating cetacean presence at each site. But the take-home message from all of this is that Brandon Bay was found to be an important site for bottlenose dolphins and harbour porpoises, where bottlenose dolphins were present on 92% of days, and harbour porpoises were present on 89% of days. And both species are foraging there. So Levesque et al. Recommended expanding the Lower River Shannon SAC to include Brandon Bay and Trolley Bay. And the results of this study support the findings by Levesque and also show that there's significant harbour porpoise presence in Brandon Bay. So protecting that site could potentially benefit both species. So thank you for listening, and I'll turn now to your questions.